Welcome to Brunda Engineering Academy. In this video, we will discuss about some practice bits on material properties and testing of the materials. This concept is common for both civil engineering and mechanical engineering students in the subjects of strength of materials and engineering materials. So, just it is a practice bits. We will discuss the practice bits. Now, first bit, elasticity is the property of material which enables it to. Elasticity is the property of a material which enables it to. So here options are withstand a high unit stress together with unit deformation, return to its original shape after removal of load. So here elasticity means the body will be returned to its original shape after removal of load. Whenever you apply, suppose if you consider a body, if you apply the loads, in this way, then after removal of load, after applying the load, it may be extends like this. The tension will be act there. So here some extension will be there. After removal of load, again it will be regain its original condition. So that property is the elasticity property. That property is the elasticity property. Next, coming to next option, next bit. All of the statements are correct except. So ductility is the property of a material undergo large permanent deformation in tension. So here ductility means it is the permanent deformation under tension. Ductility is the permanent deformation under tensile force. Tension means here under tensile force. So it is the correct one. So don't worry about that. So next one, metals and alloys for being rolled into sheets. Metals and alloys are being rolled into sheets. Suppose it is a metallic component, it can be rolled into sheets. So that means we have to apply the compression load. Okay, we have to apply the compression load. So that's why metals and alloys for being rolled into sheets, that is undergo plastic deformation in compression. Okay, permanent deformation. Plastic deformation is nothing but the permanent deformation under compression. That property is called as the malleability. That property is called as the malleability. So these two are the correct statements. Don't worry about that. Next, coming to Young's modulus of elasticity for a material depends upon the nature of loading. Young's modulus of the material depends upon the nature of loading. Actually, this is a wrong statement. Actually, Young's modulus Y or E equal to is stress by strain. Stress by strain. Ratio between stress and strain is called as the Young's modulus. This will not be depends upon the nature of loading. Okay, so it is a wrong statement. It is the wrong statement. Next, coming to this one, the reduced strength of a material under repeated or reversible fluctuated stresses is called as the fatigue. Fatigue means it is the property of the material withstand with the repeated and reversal stresses. Repeated and reversible stresses. That is called as the fatigue. So here all the statements are correct except means here it is the wrong option. So this is the right answer. Now another one. Which of the following is the wrong statement? Similar bit. Which of the following is the wrong statement? Coming to this one, which of the materials for wire drawing should be have high malleability? Materials for wire drawing. Wire drawing means here, for example, gold ornaments. So it is a material. It is a material. Gold chain. Suppose if you consider gold chain, the metallic gold component will be applied under tensile load, uh, formed into the wires. Okay, so that property is that ductility. That property is the ductility. While drawing operation is coming under the process of the property of the ductility, not the malleability. So it is the wrong option. So it is the wrong option. Next, a zero value of Young's modulus, a zero value of Young's modulus of elasticity. That means Young's modulus E equal to zero. That the material is highly incompressible. That material is highly incompressible. It is the right answer. Next, an isotropic material is a highly exhibits the same elastic property in all directions. Isotropic means it is having same elastic properties in all directions. So it is also a right statement. Next, hardness is the ability to resist the indentation. Indentation means if you apply the load on this component, some mark will be acting on the body. So hardness is the ability to resist the indentation and plastic deformation. So it is also a right statement. So out of these four, the wrong statement is materials for wire drawing should have high malleability. So it is having high ductility, not a malleability. So the wrong statement is this one. Next, coming to toughness of the material. Toughness of the material signifies strength of the material, not softening, not brittleness, fatigue resistance. Okay, softening, brittleness, fatigue resistance. These are wrong options. So toughness of the material signifies the strength of the material. Toughness of the material means here strength of the material. Next, stiffness of a material is expressed in the stiffness of the material is expressed in terms of the hardness number. Stiffness of the material is expressed in terms of the hardness number. Next, coming to another bit, lack of toughness. Lack of toughness in material implies brittleness, plasticity, ductility, softening. Lack of toughness means lack of toughness. Due to lack of toughness, material causes brittleness. Brittleness means it is the property of a material, failure of the material without having any visible permanent deformation. Failure of the material without having any visible permanent deformation. Whereas plasticity means it does not regain its original condition. Ductility means if you apply the under tensile load, next softening. So here out of these four, the correct option is brittleness. Due to brittleness, toughness due to lack of toughness, brittleness will be applied. Next, the another bit is statement. Stress is proportional to strain. Okay, stress is proportional to strain. What is that? Stress is proportional to strain. It is the Hooke's law. Okay, this Hooke's law good up to which point? Elastic limit, limit of proportionality, upper yield point or lower yield point. So this Hooke's law is good up to limit of proportionality. Who it is a very important bit previously asked in competitive examinations. So Hooke's law hold up to limit of proportionality. Okay. Next coming to another bit, Hooke's law is valid within limit of proportionality. Same thing we discussed there. And this proportionality limit depends upon either type of loading or material of test specimen, cross-sectional area or geometry of test specimen. This proportionality limit will be clearly depends upon the material of the test specimen. So this is the right answer. Material of the test specimen. Hooke's law means stress is proportional to strain. This will be good up to limit of proportionality. That proportionality limit depends upon the material of the test specimen. Okay. Next, the limiting load beyond which the material does not behave elasticity. The material, the limiting load beyond which the material does not behave elasticity is known as it is the elastic limit that will be discussed in this one. If you observe this diagram, this is the stress strain curve. Okay, first of all, you should have learn about these points A, B, C, D, E, F. Okay, so now here I am writing A is the proportional limit. Proportional, proportional, proportional limit. Up to this proportional limit, the Hooke's law will be good. Okay, up to this proportionality limit, the Hooke's law will be good. Whereas the B point is the elastic limit. Elastic limit. Up to elastic limit only, the material should have the elasticity. Okay, so the here the option is the limit beyond the which the material does not behave elasticity. Up to this point only the material having elastic property. After this thing, the material doesn't have elastic property. The material having the plasticity property. So the answer is the elastic limit. Next, coming to another bit, the below figure shows the stress strain curve for tensile test on a mild steel specimen. Okay, so it is the stress strain curve. Now the upper yield point is represented by the point. Where is the upper limit point? Okay, so for that purpose, I will explain clearly all the points. So here it is the elastic proportional limit and it is the elastic limit. Next, the C is the upper limit, upper yield point, upper yield point. It is the upper yield point. Next, D is the lower yield point. D is lower yield point. Lower yield point. That all are will be in the plasticity region. Next, coming to the point E. So here it is the point E. Okay, point E is the ultimate stress. Point E is the ultimate stress. Ultimate stress. Ultimate stress. Next, coming to the F. F is the failure point or breaking point. Okay, so at that point the material will be damaged completely. So these are the important model. This is the important model in the stress strain curve. They give the stress strain curve. They you should identify the what are the points. A is the proportionality limit, B is the elastic limit, C is the upper yield point, D is the lower yield point, and here E is the maximum ultimate stress, and F is the failure point. So these are some concepts, some practice bits on engineering materials or material properties. Okay, it is common for the both civil engineering and mechanical engineering students asked in RRB examination point of view and ECET point of view also. ECET point of view also, and in GATE low level questions, 1 mark questions, they may be asked in a theoretical way. So if you like this video, please share and subscribe our Brunda Engineering Academy channel. If you have any doubts, please mention in the comment box. Thank you.